Okay, for Excel Part 2, there are a few things that you need to do. We need to select a data set as data set 1. I'll just do Antarctic ice. We need to calculate the descriptive statistics of that. So if we use our data analysis, descriptive statistics, and I want to select from here, Control Shift down to the bottom as our input. We'll put it on a new worksheet, that's okay, and summary statistics. And there we go. Right, so it calculates the mean, the standard error, median, mode. So you won't get a mode, but that's okay. This just happens because there is no value that repeats. All these values are unique. We get a standard deviation and all these things. So the other parts of this analysis are to create a histogram of the data. And we'll just can create it automatically. So here it just calculated the histogram, but we can plot that up, or we can just take this column, insert statistical plot, statistical histogram. And there's our histogram. We can also insert the statistical plot, the box and whisker plot, right? So you'll need to make these two charts, and then you will need to do a basic interpretation of these charts. So we can see from the box and whisker plot and from the histogram that, right, our data don't look very normally distributed, right? This is skewed, right? We can see that in both plots and in the summary statistics. So you create the summary statistics table, a histogram, a box and whisker plot, and then a very short interpretation of the distribution of the data set. And if you choose something like the CO2, you could do either the average or the seasonal corrected. You don't need to do both. So we do that for 2 data sets, and then in a Word document include your descriptive statistics as a table, include your 2 charts, your histograms as figures, and your very short description of the distribution of the data. So you do that for 2 data sets, and then those same 2 data sets you will perform a regression on. So this data set table won't work for that because we have all of these decimal years. And so when we want to perform the regression, we can just try this one real quick. It's going to produce a mess. So here's the Antarctic ice, and let's try sea level. So we'll take this and put, oops, where did I put that? Here we go, this sheet. Right. So if we try to plot the mass versus the sea level curve, we get a line here, or we get a scatter plot, right? And it looks like there's some kind of correlation here. But what we're comparing is the mass in 2002 with the sea level in 1993, which is not the appropriate comparison. So we need a table where the values of the years that we're comparing are the same. So in this decimal degree format, that would be quite a headache. So to make this process slightly easier, I have created a new data table, or new Excel document, datasets2, where I have collapsed all the decimal years into one value. So I've calculated the average for each dataset for a given year. So this data is not as detailed as the original datasets, but it's much easier to find the proper values to calculate the regression line. So if I'm going to do Antarctic sea ice, I can take these values, copy them, and I'll just put them in a new tab. And so this data goes from 2002 until the present, to 2020. And so if I'm going to compare this to sea level goes back to 1993, but I only want the values from 2002 until the present. So I can copy these and put these next to this. Oops. Undo. There we go. So the year, and this was sea level. So now I have the years, the corresponding years matching. So I can create a scatter plot of, I can create a scatter plot of these two columns, and this is the appropriate data set to perform a regression on. It's also the appropriate data set to calculate the correlation of these values and these values. So that'll give us a correlation coefficient. We can create a scatter plot of these two data sets and add in a linear trend line or regression line that we can also use to figure out a goodness of fit from. So this will calculate our R-squared goodness of fit for the regression and the correlation coefficient through the Correl function. But the key here is that you need to match the two values for the appropriate year, for the same year, when you're doing this regression. So that is why there is a new dataset 2 for that second part.